farm in Caribou County, Idaho, and we plant, we do about 7,500 to 8,000 acres each year of wheat, barley. We now grow pulse crops, cover crops, do mustard, and we tried growing quinoa this year. So it's our first year on the bioactive process. It's been a learning curve, but very excited with what I'm seeing. Very happy with the results and very happy with the support that Gary and everybody has given to us, and it's amazing to see what can happen when you empower the plant to do what it should do naturally, and really happy with how it's going. Can't wait to get in the combine and harvest.
At Dan Lakey's, and this is his spring wheat that he planted at about 100 pounds to the acre, which would be close to the 2 bushels. It is in the flowering stage right now. Hasn't rained since June, about 15th of June, just a few showers, but it's definitely doing well. It's got a very large root system. In the mid row you can actually find a lot of fine roots, hyphae exploring the mid row. The flag leaf is clean, no disease, and no mineral deficiencies. It's running about 3.5% nitrogen in the leaf, nitrogen tissue test, compared to some of the fertilized ones. This is running at a higher nitrogen rate, so it is showing that we're helping wheat do its own nitrogen fixation by photosynthesizing at a higher rate, putting off a lot of exudates off these roots to feed the free-living nitrogen-fixing bacteria that can fix enough nitrogen for this wheat to grow. It can actually produce up to 80 pounds to the acre of nitrogen through the system with wheat. It's well-known, published science that says that. The roots they have a lot of fine hyphae. It looks like cotton coming off of all the roots, so we know it has a lot of mycorrhizal fungi interacting with the soil, finding all the minerals, so that this leaf of this plant is rich in minerals to attract CO2 to this leaf to make more sugar. So we look forward to the harvest.
It's hard to make sense of it at first. It's a totally different way of thinking about how we grow this, and at the price, and that's why this hasn't been a good performing variety. In fact, we should have hauled all of it to the elevator because we were done with it. This is our 3rd year. We had 2 or 3 years under it. We didn't like it, so we were going to go back to a Jefferson or a 9668 or something. And I did use Jefferson at Bear Creek, and so we were done with this, and we just planted it because we had it in the bin, and it looks a lot better than any of the other years that we've used. Yeah. And what I hauled to the elevator, I was getting $4.60 a bushel. Yeah. And so even at planting at 110 pounds and the herbicide I've got just a little over $10 in seed and chemical in this per acre in this crop.
So you're making money the day you seed it. You'll get it back.
Yeah. So that's.
What do you find you get for protein?
Yeah.
You get it.
If you plant into a legume stand, I've got 19.6% protein.
On spring wheat.
Yeah.
Irrigated, right?
Yeah.
And that was under irrigation.
Yeah.
So I mean,
what do you expect here though?
You'll be 13, maybe. In that range. It's really hard to say. It depends a lot on the year, but we don't pinch. Our grain is more plump, and the pinched grains, the screenings, are where the high protein is. Mm-hmm. So we may not pinch down, and we may not get that high protein, but you'll get the heavy bushel weight. Okay? So where if you're on fertilizer on a really dry year, it's all the screenings, the fine ones that build the protein up, and then you get docked because you're too light. Hey? You got a lot of light grain. Where our grain is always heavy, and you'll find that it'll fill right to the very top, and if it gets enough rain, it'll flower another row, and that's exactly how it's adjusting itself, even though it's very heavy stand. Fertilizer is causing a drought, so we put less seed on and more fertilizer, and that's how everyone's going, and it's not the right direction, because fertilizer causes a drought, and it just makes smaller. You don't have all this root system feeding and finding the moisture out of every little drop of water that's left. And that's what mycorrhizal fungi does. And if you put any ammonium phosphate there, then that mycorrhizal fungi is not going to be in your soil. And every agricultural land, ammonium phosphate goes under every wheat plant. And it's just not getting the nutrients and the water, you know, and or the defense against all the soil-borne pathogens that mycorrhizal net puts over your root system.
What'll happen with this system is it'll about late tillering, and all the Australians that I've talked to and the Canadians, everybody said don't panic, but about late tillering it won't look as good as your fertilized crops. You know, it'll kind of just go lethargic, but don't worry, it'll snap out of it. And Kurt had driven out here during that time, and he said, oh yeah, I thought you'd made a mistake. I thought you'd screwed up. And then he said I was out there a couple weeks later, and I could not believe the change. And about a month ago, I was out here, and it was going through that change. You had dark green spots, and you had lighter green spots. That you know, right there where we come in, it was a little pale, and it's found what it needed and picked up, and it snapped out of it like.
So a lot of its energy is being put into this mid-row here. All this fine roots, in those days, it's putting its sunlight energy into this effort. So that on a day like today, when it's starting to fill the grain, these roots are actually, as far as the plant's concerned, those are water tanks stored. You know, you start respirating and burning off roots, they give off water. And so microorganisms and roots, organic matter and material is all in this soil now, and now it's starting to take it back up into the plant. But if it didn't have this system, you wouldn't have the stored carbon and the stored microbial life that's there to support this plant through to the end. The leaf itself, if it's positively charged, it's photosynthesizing. You know, if you can't tell how this leaf is actually growing, but in understanding the physiology of the plant is when it's on nitrate nitrogen, this leaf is positively charged. If it's on ammonium, ureas, this plant will be negatively charged, taking up phosphorus and chloride at a higher rate, and that closes down the stomata, so this plant can't breathe the CO2 from the air as well, because it takes a lot of breath to put all this root down in the soil. A lot of CO2 has to be taken in. Some plants can put in 5 times more carbon into the soil than what it takes to grow the whole top. So it's acting like a legume. It's not making nodules, but guess what? There's free living nitrogen fixing bacteria. Fixing nitrogen with the sugar this is giving off, because this is positively charged, making more sugar.